We are Team 3.1 from BMS College of Engineering, Bangalore, participating in Texas Instruments Innovation Challenge India Analog Design Contest 2014. Our project is Duo Solar Micro Inverter. Solar panel gives out maximum power only at a particular voltage and current level, which is called as maximum power point of the panel. Maximum power point of the panel is a function of solar irradiance and temperature. Real-time tracking of this voltage and current values is called maximum power point tracking. Since the conventional solar installations use string topology in which each panel is connected in series, each panel doesn't operate at its maximum power point and the total power output is reduced by the poorest performer in the string. Shading or failure of a single panel will affect the operation of other panels in that string, thereby resulting in minimum output power. Solution to the above problem is microinverter. Microinverter attached to each panel allows it to isolate and tune the output of that panel independently. Partial shading or failure of a panel will not affect the operation of the other panels. Since each panel is tracked independently, microinverter systems give out the best possible power output. The TI components used in our project are UCC2732 gate driver IC, TL2575 12-volt switching regulator, LM358N operational amplifier, and TMDS-DOCK28027 experiment kit, consisting of TMS320F28027 piccolo control card. It has onboard ADC channels and high precision PWM channels. It generates high frequency PWM signals to the gate driver. The entire circuit obtains power from the onboard power supply unit consisting of TL2575 12-volt switching regulator, LM7805 5 volts linear regulator, and LM7815 15 volts linear regulator. Voltage sensor is constructed using voltage divider network and low pass filter. Operational amplifier LM358N is used as a buffer amplifier. The gate driver is used to fire the PMOS switch from high frequency PWM signals generated from the controller. It uses UCC2732 gate driver IC from Texas Instruments. The buck converter consists of IRF 9520 PMOS switch, IN 5820 Schottky diode, 2 mH inductor, and 10 microfarad capacitor. The solar panel output is connected to the input of the buck converter. PMOS switch is driven by the gate driver circuit. The buck converter along with controller achieves the maximum power point tracking. PWM output of the controller is controlled using reference signal from the potentiometer which mimics the sensor part. Buck converter output is displayed on the digital storage oscilloscope. Initially, the PWM output has 80% pulse width. When the reference signal from the potentiometer is decreased, the pulse width of the PWM control signal reduces and reaches a minimum value of 20%. Here we can also observe the variation of current drawn by the buck converter with changes in pulse width of PWM control signal. This variation of current in turn changes the panel output voltage. The MPPT control algorithm controls the pulse width of the PWM signal to operate the solar panel at maximum power point. In this way, we can perform maximum power point tracking of the solar panel. Future work. Development of better control system for maximum power point tracking to increase stability and efficiency. Providing isolation to the solar panel by designing flyback converter. Maximum power point tracking of two panels independently from a single controller. Design of common DC bus to combine the DC power output of multiple MPPT trackers.